Hi everyone, this video is on factoring quadratics by completing the square. So this is just another method of finding the roots to a quadratic that we can add to the ones we have taught you already, like the GCF, the X method, or the generic rectangles. So let's pretend that I give you a quadratic equation that looks like this: x squared plus 2x minus 3 equals 0. So if you noticed in this equation, if you approach it and I ask you to factor it, the first thing that you're going to go ahead and see is if a is equal to 1. And you notice that indeed it is. So you're going to go straight to the x method. And on the top you're going to put -3, and at the bottom you're going to put 2, or the b value, and the c value on the top. Then what you're going to do is you're going to try to figure out two factors. When multiplied together gives you -3, and when added together gives you a 2. And what you're going to notice is that you can have a 3 and a -1. And when I multiply those together, I get a -3, and when I add them together, I get a 2. And you will notice that now you have it in factor form: x plus 3, x minus 1 is equal to 0. And you will see that with ZPP, our property, our roots are at x equals -3 and x is equal to 1. So let's go and check this out with decimals. So now we're checking our work with decimals. And if you notice, I substituted x squared plus 2x minus 3 into decimals, and I got x squared plus 2x minus 3. And immediately decimals graphed it for me. Now I check my roots and I notice that it's at x equals -3 and x is equal to 1. And when I check my work, it is true, those are my roots. However, in this video I'm going to show you a different method. Now this method might seem a little bit more complicated, but I want you to keep an open mind because this method comes in handy with more difficult problems. So we're going to go ahead and use the same quadratic equation that we used before. And you notice that we used the x method and it was easy for us to factor this out. But again, we're going to use this more complicated way of factoring quadratics with this easy one. So that way when we get to a harder problem, you'll understand it. So the first thing you always want to look when completing the square is that you want to see if a is equal to 1. If that condition is met, we can use the method of completing the square. So the first step has been checked off. Now what I want to do is I want to go ahead and take my equation and take the c value and place it on the other side of the equal sign. But remember, with equations, we can't just send it to the other side. So what we're going to do is we're going to take the additive inverse of it, which is +3, and we're going to add it to both sides. Once we do that, our new equation turns into x squared plus 2x on the left side and a 3 on the right side. Now if you noticed, I've left a spot here. Now this spot is going to come in handy because we're going to place something in it as we are completing the square. Now we're going to go ahead and find the number that goes in this place in order to complete the square. And we're going to go ahead and use this formula to find it. Now it is pretty simple. We need to identify b, and in this case our b is 2. So I'm going to substitute it on the top, divide it by 2, and then take the square of it. And I'm going to go really slow with this. 2 divided by 2 is 1. 1 to the power of 2 is 1. So that's my magic number that's going to allow me to complete the square. So I'm going to go ahead and use that number, and I'm going to come back to my equation and go like this: 2x squared plus 2x plus 1 equals 3 plus 1. Now I have to add it to both sides, because those are the rules with equation. Whatever you do to one side, I have to do it to the other side. Now once I've done that, I've completed the square. You will notice that the left side actually turns into x plus 1 to the second power. And on the right side, I have 3 plus 1 is equal to 4. Now that I've done that, I've made it into a perfect square. So my next step is that I'm going to go ahead and clean it up by taking the square root of both sides. On my left side, I notice that the power of 2 and the square root cancel each other out, and I'm left with x plus 1 equals 2 plus or minus 2. Now you're going to ask yourself, where did I get the plus or minus 2? Well, remember from previous lessons, we noticed that plus 2 times plus 2 is equal to 4. But we also noticed that negative 2 times negative 2 is also equal to 4. And that's where we're getting the plus and the minus here. Once I've done that, I'm going to go ahead and solve two equations. One of the equations is going to look like this, x plus 1 equals 2. And the other equation is going to look like this, x plus 1 equals to negative 2. So I'm taking my positive sign here and my negative sign on the next one. And I'm going to go ahead and solve for x. So on this side, x is equal to 3. And on this side, x is equal to, if I add a negative 1 to both sides, is equal to negative 3. And I just noticed I made a mistake for skipping a step. This should be add a negative 1 to both sides. So my actual answer is x is equal to 1. So now what you've done is by completing the square, you found the roots to this. And if you remember from the previous video or the previous session that the roots of this quadratic are equal to x equals 1 and x is equal to negative 3. And that's the method of completing the square.